Hello my dear students, welcome back to Learn Physics. In today's video, we are going to continue with the kinematics portion, and in that we were discussing about the relative velocity, right? Then here in today's video, we will be discussing about relative velocity of rain with respect to man who is with respect to relative velocity of rain. See, if a person is walking, in which direction he should hold his umbrella. Suppose the man is moving in a bicycle, in which direction he should hold the umbrella. Such kind of questions come. How we will be solving this one? So here, velocity of rain, I am taking it as VR. Velocity of man, I am taking it as VM. So both are moving, rain also moving and man also moving. Both are moving, then we should hold the umbrella in the direction of relative velocity. For that, relative velocity with respect to rain only we should hold the umbrella, right? Relative velocity of rain with respect to man we should find out. Just opposite to that direction we should hold the umbrella. That is VR minus Vm. How can we represent that one in a diagram? How can we represent? See, velocity of rain. Suppose rain is moving like this, VR, and man is moving like this, Vm. Then the relative velocity will be VR minus Vm. While we are taking VR and Vm and the resultant of these two vectors, it will be VR plus Vm only. So here we can consider it as VR plus minus Vm. For that I am considering V minus Vm in this direction. So the relative velocity will be like this. This will be the direction of relative velocity. So rain will be falling in this direction. He should hold umbrella just above that. Or we can find out the theta with respect to the rain. What will be the value of theta? Okay, for that tan theta you need to find out. Opposite side Vm divided by VR will give you tan theta value. Clear? So this is how we will be finding out the relative velocity of rain. So a person is traveling with a particular velocity and rain also moving. If both are moving, we should hold the umbrella in the direction of relative velocity. Okay, so such kind of some numericals we are going to do it today. Okay, some numericals are there in your NCERT textbook also, and along with that some questions from DC Pandey sir's book also we will be doing. Here the first question is, a man is walking on a level road at a speed of 3 km per hour. Raindrop falls vertically with a speed of 4 km per hour. Find the velocity of the raindrops with respect to the man. In which direction the man should hold his umbrella to protect himself from rain? For that the data given are, man is walking on a level road at a speed of 3 km per hour. So velocity of man is 3 km per hour. Now, raindrop falls vertically with a speed of, so velocity of rain is 4 km per hour. Find the velocity of the raindrop with respect to the man. We need to find out, and the direction in which he should hold his umbrella to protect himself from rain. That also asked. So VRM, how can we find out? So man is moving with a velocity of 3 km per hour. Vm, that is equal to 3 km per hour. Rain is falling vertically downwards 4 km per hour. This is velocity of rain. So how can we find out VRM? VRM will be here, this will be minus Vm. This is VR. Relative velocity will be VR minus Vm. So he should hold his umbrella in this direction. Okay, so how can we find out VRM? This is VRM. This is Vm, right? This is Vm minus Vm, this is VR. So VRM will be hypotenuse. VRM equals root of VR square plus Vm square. Therefore, it is 16 plus 9. Therefore, it will be equal to 5 km per hour. So what will be the direction? See here I can take this as consider theta. With respect to rain, it as theta will be tan theta equals opposite side divided by adjacent side. Vm is 3 by 4. Theta equals tan inverse 3 by 4 with respect to the vertical. Okay, so he should hold his umbrella in a direction tan inverse 3 by 4 with respect to the vertical. Clear? Next one, rain is falling vertically with a speed of 35 meter per second. So velocity of rain is given as 35 meter per second. Wind starts blowing after some time with a speed of 12 meter per second. Wind starts blowing at a speed of 12 meter per second from east to west. Okay, then in which direction should a boy waiting at the bus stop should hold his umbrella? So here wind is blowing and rain is moving. So rain is falling vertically downwards. So rain is falling vertically downwards and wind is flowing from east to west. So this will be the direction of east to west. 12 meter per second velocity of wind. Okay, rain is 35 meter per second. Now, a boy waiting at the bus stop should hold his umbrella in the direction of relative velocity of wind and rain. So, here we can write it as 35 velocity of rain 35 meter per second minus VW, that is 12 minus 12 meter per second. So he should hold his umbrella. The relative velocity will be acting in this direction. So he should hold his umbrella like this. Therefore, VRW will be equal to root of 35 square plus 12 square, that is root of 1225 plus 144. Therefore, it will be equal to 1369 meter per second. Okay, you can solve and find out VRW. Direction, how we will with respect to the wind and with respect to the rain, what will be theta? Tan theta equals opposite side divided by hypotenuse adjacent side. Theta will be equal to tan inverse 12 by 35. So clear children. So if rain and man is moving, rain is falling at the same time, man is moving, rain is falling at the same time, wind is blowing. So we should hold the umbrella in the direction of relative velocity. That one you should be thorough with that. And how to find out the relative velocity value? You can take the right angle triangle, hypotenuse square equals base square plus altitude square. That formula you can consider, and to find the direction you can take the value of tan theta. Clear? Next question is, a man standing on a road has to hold his umbrella at 30 degrees with the vertical to keep the rain away. He throws the umbrella and starts running at 10 km per hour. He finds that raindrops are hitting his head vertically. What is the speed of the rain with respect to the ground? A man standing on a road has to hold his umbrella at 30 degrees with respect to the vertical. So this is vertical. He is holding his umbrella at 30 degrees. Okay. Then to keep the rain away, he throws the umbrella and starts running at 10 km per hour. So he is moving with now he starts moving with a velocity of 10 km per hour. Now he finds that the raindrops are hitting his head vertically. When he started moving with a velocity of 10 km per hour, he finds that the relative velocity, that is rain, and when a relative velocity is acting, it's just vertically downwards. What is the speed of the rain with respect to ground? Rain with respect to ground. So here in this case, when the man was standing still, standing at one position, then he was holding the umbrella at 30 degrees to escape from rain. That means the rain was making an angle 30 degrees with it's not falling vertically. right? So this will be the position. So here this is the velocity of the rain. It's not falling vertically. The man is holding his umbrella at 30 degree with respect to vertical, means the rain is falling at an angle 30 degree with respect to vertical. Now I can divide this into its component. This is VR cos theta and this is VR sin theta. Right? So this VR sin theta, that is VR sin 30, that is equal to VR by 2. This will be VR by 2. Now, when he started moving with a velocity of 10 km per hour, he felt that it is falling vertically in the direction of, so when he started moving in this direction, 10 km per hour, he felt that it is falling vertically. So this will be equivalent to this VR by 2, this will be equivalent to the 10 km per hour. That's why it is falling vertically downwards. So therefore velocity will be equal to 20 km per hour. Now we will do another question the same way. Another question. A person standing on the road has to hold his umbrella at 60 degree with the vertical to keep the rain away. He throws the umbrella and starts running at 20 meters per second. He finds that raindrops are hitting his head vertically. Find the speed of the raindrop with respect to the road and to the moving person. So both we need to find out. Here, when a person is standing at the roadside, he is holding his umbrella at an angle 60 degree with the vertical. So this is the velocity of the rain. So here we can divide it into components, VR cos 60 and this is VR sin 60. Okay, now the person starts moving with a velocity of how much is the velocity? It's given 20 meters per second. He is moving with a velocity of 20 meters per second. Therefore, velocity of rain with respect to ground will be VR minus VG. Right? So, VR minus VG, velocity of ground is equal to 0. Therefore, it is equal to VR. Here we know that VR sin 60 equals 20 meters per second. Therefore, VR equals sin 60 is root 3 by 2. So, 20 into 2 by root 3, 40 by root 3. Okay, now we need to find out velocity of the rain with respect to the person. That is VR minus VP. So the person is moving like this with a velocity of 20 meters per second. So this is VP and this is velocity of the rain. Then VR minus VP, how can we find out? VR is this one, this is VR and this is VP. Now he feels it is minus VP. He feels it is moving vertically downwards. So here it will be VR minus VP. It is acting like this. So which is the vertical which is acting over here? That is VR cos 60. VR cos 60. So instead of drawing this diagram itself, we can find out in the question itself it is given when it is moving at an angle 60 degree. When he is running at a velocity of 20 meters per second, the rain is falling vertically downwards. So the vertically downwards means VR cos 60. Therefore VR by 2. So VR we got it as 40 by 3 root 3 divided by 2. So 20 by root 3 meter per second. So here this is how we will be finding. So velocity of the rain with respect to the person and velocity of rain with respect to ground. So for remembering that, you can write it as VR velocity of rain with respect to ground will be VR sin 60, that is equal to sine of this angle will be equal to the velocity of the person. And if you are taking VR cos component, it is vertically downwards. So if this diagram is there in your mind, you can write down. Okay, clear children? So I think, so these are some of the questions relating to the rain, relative velocity and rain. So I think you would have got an idea about this one. And the next video, we will be coming with some more numericals. Thank you for watching. Bye.